In this video, we are going to look at the effects of imposing a minimum wage in a monopsony labor market. In order to compare the effects, we are also going to look at the competitive labor market first. So let's start with a basic view of the labor market. In a competitive market, wages and employment are determined by the interaction of labor supply and labor demand. Firms demand labor because it contributes to production, and workers supply labor in exchange for wages. In the standard model, we have the labor demand function that is downward sloping because firms hire fewer workers as wages increase. Each additional worker adds less to output. The labor supply curve is upward sloping because more people are willing to work and to work more hours as the wages increase. So let me label those two functions here. So we have labor demand and we also have the labor supply. Where those two curves intersect here, we find the equilibrium wage and employment level. So the equilibrium employment level, we are going to mark this with L star, and the equilibrium wage, we are going to mark this with W star. This point reflects a balance. Everyone who wants to work at that wage can find a job, and firms hire as much labor as they desire at that wage. Now let's see what happens when a minimum wage is imposed above the equilibrium wage. So I'm going to draw this minimum wage up here. So note that the minimum wage very much works like a price floor. So here we have the minimum wage that is marked in red here. And now at that higher wage, more workers want to work. So you can think about this point here. But labor supply increases, but firms demand less labor because it's more expensive. So labor demand decreases. The result is an excess supply of labor, or think about this as unemployment, and the size of the unemployment depends on how elastic supply and demand are. But as the classic textbook prediction, we are now having the result that the equilibrium labor in the market declines, in the sense that we are now at L prime and not at L star anymore. Now, this prediction depends on one critical assumption, that the labor market is perfectly competitive, meaning workers can easily move between employers and firms and they have no power to set wages. Now, let's consider a very different scenario, that of a monopsony. A monopsony is a labor market with a single dominant employer. Think of a mining town with only one mine. In this setting, the firm faces the upward sloping labor supply curve directly. If it wants to hire more workers, it must raise wages, not just for the new hires, but for everyone that is already employed. So here you see the setup of the monopsony labor market, where we have the output price that is equal to 1. Note that the output price equal to 1 doesn't matter or doesn't change the result. And now think that we also have a production function that is equal to Q is equal to 5 times the square root of L. Okay. And then we also have the labor supply function that is written as L is equal to 10 times W. In the sense that if you are increasing W, that means that more workers are willing to work. Note that this can also be written slightly differently, in the sense that we can express the wage as the number as a function of workers, and so that would be L divided by 10. Now, the profit maximization occurs where the firm is having revenue. So we have the revenue is simply 5 times the square root of L, since the price here is equal to 1, so I can write the price here, but it doesn't really matter. So that would be the revenue minus the cost. So the cost would be the wage, so L divided by 10 times L. So in this case, we have here the revenue of the firm, and we have the cost of the firm. And the choice of the firm is to choose L such that it maximizes this function. So you can show that the function is maximized when you have the following what is called first order conditions. So let's call this the first order conditions. Note that those first order conditions are coming out of calculus. And so we have the 2.5 times L to the power of negative 0.5 is equal to the L divided by 5. Okay? So L and L, that are the number of workers that satisfies this condition, is going to maximize profits. So this part here is called the marginal revenue product of labor. Let's call this a marginal revenue product of labor. And that is basically saying what is the additional revenue for the firm if it hires one more worker. And then the other part here, this part here, is the marginal cost associated with labor. Now let us graph this in a 2D graph. So similar as before, we have let's call this the wage, and we have here the number of workers, labor. Now, given those functions, the marginal product of labor approximately looks like this. Okay, so let me just say the marginal revenue product of labor. And then we also have the labor supply. So this is the labor supply. And then we also have the marginal cost associated with the labor supply. And that function is going to look like this. So this one here is the marginal cost associated with labor. Okay? Now, the profit maximizing condition for this firm is where the marginal revenue product of labor is equal to the marginal cost of labor. So that would be this point here. Okay. Now this is the number of, let's call this L star. This is the equilibrium number of workers. And note that this resides in the wage that is marked that is marked with the supply function. So here we have W star as the equilibrium wage in this model. Now, suppose that in this case, we are actually looking at minimum wage. And note that the minimum wage in this model, I'm going to be placing right here. So we call this part here, we call this the minimum wage. And now note that the minimum wage is set such that it intersects where the marginal revenue product of labor intersects the supply function. Okay. Now note that in this case, what we have is that the marginal cost for the firm is equal to this to the line of the minimum wage. So, for example, at this point here, at the initial point, the marginal revenue product of labor is still higher than the marginal cost of labor, which would be this point here. So since that there's the marginal revenue product, the additional revenue product for the firm is higher, the firm is going to continue to work to hire more workers. And it turns out that in this model, the firm is going to hire more workers up to the point where the supply function of workers or the supply function of labor intersects the marginal revenue product. So now we have here this, let's call this L prime, and this is going to be the new labor demand for the firm. Now note that here in this case we have set the minimum wage, but the minimum wage actually led to an increase in the employment level in this model.